Hello everyone. Good evening. Good evening to all of you. So before moving on to the session, I would like to launch a poll to check the class status. Okay. Good evening, Priyanka. Good evening. So I want all of you to answer for the question. Just tell me whether I am visible and audible to all of you. Okay. Great. Fine. Fine. Okay. So once again, good afternoon or good evening to all of you. So today we are going to start with a new chapter, kinetics. Okay. So moving on to the chapter, chemical kinetics. So in this topic name, we have a new term called kinetics. Okay. So this kinetics has been derived from the word kinesis. Okay. So which means movement. Okay. So kinesis means movement. So kinetics. So it is nothing but the chemical movement. We are going to study about the movement of the chemicals in this entire reaction. Okay. So movement in the sense the rate of the chemical reaction. Got it? So mainly we will focus on this only here. Suppose here I have a car, right? Okay. And the car is moving. And also I have a bread. So if I keep this bread for many days, what will happen to this bread? Will it remain same? Will it remain same in its form? Or it will change to some other form? It will transform to some other form. What do you guys say? Will it remain fresh for 10 days or 20 days if I keep this outside? Say yes or no. Students, am I audible? I have asked you guys a question that this is a bread. Okay, if I keep this bread for a long time outside, like more than 3 days or 5 days, will it remain fresh after 5 days or no? No, very good. So there will be some changes, right? From this form to the another form. So that is actually nothing but the chemical transformation. So it will become like this, no? So that is nothing but something has changed. Okay, so chemical transformation has occurred. So you see here, two compounds A and B, when they react with each other, when they collide with each other, they form a product. So when A and B are in movement, okay, so there is a formation of the product and we are going to study about the rate of the reaction and many things we will discuss here in this lesson. Okay, so this is the main concept of this lesson. And the topics that we are going to cover here in this lesson are the rate of the reaction, rate law, order and molecularity of a reaction, integrated rate law for first order and zero order, Arrhenius equation. Then at last we will discuss about the collision theory. Okay, so these are the five main topics which we are going to cover in this entire lesson. Okay, so we will try to do as much as possible. So let me take the first topic for now, which is the rate of the reaction. Okay, so the learning objectives under this rate of the reaction topic is we will study about the rate, average rate and instantaneous rate, and thirdly we will study how to write the expression for the rate of the reaction. Okay, now let's do one by one. So this is the first main topic, and in that main topic we have these three subtopics. Okay, so let me go for the rate of the reaction. So what is the rate of the reaction? What is the other name for rate? Can anyone tell me the other name for rate? It is also defined as dash. Rate is otherwise called as dash. Can anyone fill the dash? Very good, Nagashri and Jabun Sultana. It is actually called as speed. Okay, it is actually called as speed. So we are basically going to study the speed of a reaction. Again, I'm taking this car. Okay, so if I and this car is moving. Okay, and this car is moving. So how to write the displacement? How to write the displacement for this car? Displacement is denoted by the letter S, and it is nothing but the change in position divided by change in time, right? So instead of this car, okay, instead of this car, if I take a chemical reaction which is occurring in a round bottom flask, all of you can able to see, right? So we have a liquid and some bubbles are coming out from this container. So here a chemical reaction is happening. Now to study the rate or the speed of this particular reaction, it is denoted as the change in concentration divided by change in time. All of you know what is concentration, right? Concentration is nothing but the strength of the reaction. Got it? So for a chemical reaction, we represent the rate in terms of concentration, and for any physical changes, we write in terms of position. Okay. JNV Kadapa students, how many classes you are expecting from your side for me to complete this chapter? Can you mention that? How many classes you want? Just let me know that first and I will tell my thing later. Okay, okay. Mostly I will complete this in 3 class. Okay, 3 class or 4. Will not go to 4. I'll try to complete it within 3. Is it all right? Okay, fine. Now see, yeah, this is all about the rate for chemical reaction. We used to represent the rate in terms of concentration by change in time. Okay. Now, what is the unit of this rate of reaction for chemical reaction? So, in the numerator, we have concentration. In the denominator, we have time. So, it is nothing but concentration divided per time. So, the unit of concentration is mole per liter. So, in place of concentration, you have to write mole per liter, and in place of time you have to substitute second. Okay, so it is mole per liter per second. So this is the unit of rate of the reaction in terms of concentration. Okay, now what is the unit of rate of the reaction in terms of partial pressure? Instead of this concentration, if I have pressure, what will be the unit? For pressure, what we have to use? We have to use ATM, right? Atmospheric pressure. So instead of mole per liter, use ATM. So the unit will be atmospheric pressure per second. Got it? So these are the units for rate of the reaction in terms of concentration and in terms of pressure. So these two are very important. Okay? Clear? Yeah, very good, Jabrun. It is atmospheric pressure per second. Correct. Now, moving on to the next slide, I would like to take a reaction for you. Okay, so let me consider a reaction in which a reactant is getting converted into a product. Okay, now as goes on, the concentration of the reactant will be decreased, right? Because reactants concentration is getting converted to product. So as time goes on, what happens? The concentration of the reactant will get decreased. So I can say that the reactant concentration is getting disappeared. So in that case, I can say that the rate of disappearance of R, rate of disappearance of R. So we know how to write the rate. Rate is equal to change in concentration. So here disappearance means decrease in concentration of R divided by time taken. Okay, rate of disappearance of R is equal to decrease in concentration of R divided by time taken. So that decrease in concentration is denoted by the letter delta. Okay, so if I put a bracket like this, square bracket means it denotes the concentration. You should not use curved bracket. This is wrong. Okay, you have to use only the square bracket because that square bracket denotes the concentration. Okay, so decrease in concentration of R divided by change in time or time taken, which is delta T. So this decrease is denoted by the symbol minus here. Okay, so for the disappearance, we have to denote that using minus sign. Got it? Now, what will happen to the rate of product? Rate will appear, right? Sorry, the product will appear, right? So, what we have to write? We have to write the rate of appearance of product. Rate of appearance of product means increase in concentration of the product divided by time taken. So, that increase is denoted by the symbol plus into delta P divided by delta T. Got it? So the reactant is denoted by the letter minus and the product is denoted by the symbol plus. Now, if I draw the graph between this concentration and the time taken, if I draw the graph between the concentration and the time taken, okay, I will get a curve like this. Okay, so at time t1, this is the concentration of the reactant at time t1. So let me erase everything which is there on the slide. Yeah. Now after some time, this is the time, okay, time t2. Now in that case, what will happen after some time? Suppose if this is 10 second and this is 20 second. So if I'm moving from 10 second to 20 second, some of the reactant would have got disappeared. Okay, so the concentration of the reactant might have got decreased. So it is getting decreased from R1 to R2. You see here, it is getting decreased. Okay, so as time goes on, the concentration of the reactant is decreasing. Now, in the same time, yeah, in the same time, what will happen to the product concentration? It will increase, right? Thus, at time T1, this is the concentration of product. Okay, and the time T2, concentration of the product is increased from P1 to P2. Got it? So this is the graph which denotes the decrease in the concentration of the reactant and increase in the concentration of the product at time T1 and T2. Got it? So is it clear for all of you? Shall I go for the next slide? So all of you can able to write the rate of a reaction for the given reactant and product, right? It's very easy, no? Shall we go for the next? Any doubt from this? Okay, okay. So I will move on to, yeah, I will move on to the next thing again. I am going to take a reaction in which R is giving the P. Okay, so yeah, so this was the thing which we have discussed already. So what do we understand from this? As concentration of the reactant is decreasing, it is multiplied by the number -1 to make rate of the reaction a positive quantity. Okay, so always to denote the disappearance of R, we have to keep this -1 in front of the concentration of the reactant. Okay, clear? So moving forward with this, I'm going to discuss with you the types of reaction. There are three types of reactions. One is fast reaction. The second is moderate reaction. Yeah, the third is the slow reaction. Okay. So what is the fast reaction? What is meant by a fast reaction? I will take you an example. HCl and indicator. Okay. HCl and some indicator is present inside this conical flask. And to this, I am going to add the sodium hydroxide. So what will happen if HCl and NaOH reacts with each other? Can anyone give me the product of this reaction? HCl plus NaOH. It will form, yeah, very good. NaCl, right? NaCl plus H2O, which is a neutralized reaction. So HCl is an acid and NaOH is a base. So acid plus base gives a salt. Very good, students. Very good. Yeah, so it is a neutralization reaction. It is a neutralization reaction. So neutralized solution is forming. Okay. So the time taken for these two reactants to react with each other will be very, very small. Okay. Means the delta T will be very, very small. And the R, what is this R? The rate. If the time is very small, the rate is very high because within a very few fraction of second, the reactants are getting converted into a product. Okay, means the speed of the reaction is very high, which is nothing but the rate of the reaction. Okay, so all acid-base reactions will fall under this fast reaction category. Okay, so this is one of the example where the rate of the reaction is very high and the time taken by this is very small. Got it? Now the next is moderate reaction. This is the second type. So I am taking hydrogen peroxide as an example. Okay, the decomposition of this hydrogen peroxide H2O2 will give rise to the water molecule and oxygen. Okay, here for this conversion to take place, the time period is not too small or too large. Okay, so it will take a moderate time. Okay, not very small or not very large. So it will take a moderate time to get converted into a product. So what are the examples which will fall under this category? Inversion of sugar cane or cane sugar and hydrolysis of starch. Okay, these two will fall under moderate reaction. Now the third reaction is slow reaction. What is meant by slow reaction? So let me take a metal. Okay, this is a metal and this is the other side of the metal. Other side in the sense after a long period of time, this particular metal is getting converted like this. Okay, so what is this? What is this? What will be the time? What will be the time taken for this metal to get converted to this product, to this thing? Yeah, in the electrochemistry itself, we have seen this, no? Very good. The time taken for this reaction to take place is very large and now the rate is very small. The rate of the reaction is very small, means it will get rusted very slowly. Okay, it will take many days, many months to get converted from this one form to the other form. Okay, so some more examples are conversion of graphite to diamond, and this is actually the rusting of iron. Okay, this is all about the types of the reaction. So in the first slide, the very important thing that you need to note down is the unit. Okay, unit of rate of the reaction in terms of concentration and pressure. Then next, you should know how to write the rate of the reaction in terms of reactant and product. Third thing is types of reactions. Fast, moderate, slow, and in each case, I told you what is the criteria for delta T and R, and also I have given some examples. Any doubt till now? Shall I go for the next topic? Yeah, okay. The next topic is average rate of the reaction and instantaneous rate of the reaction. So let us first discuss about the average rate. Okay, what is average rate? The rate of reaction measured in certain interval of time. The rate of the reaction measured in some interval of time is called as average rate. So let us consider a reaction, okay, where R is giving P. So if I want to write the average rate of this reaction, it is equal to total change in concentration divided by total time taken. So again, I'm going to take the same graph which we have discussed already in one of the previous slide. Okay. Now this is the graph. What is the total change in concentration? Total change in concentration means it is nothing but delta R in terms of reactant divided by delta T. If I am going to write this in terms of reactant, then I have to put a minus, right? So average rate will be equal to minus delta R by delta T, and this delta R is nothing but change in concentration where the value is going to be equal to final concentration minus initial concentration. Okay, so it is R2 minus R1, and for delta T, it is T2 minus T1. Now, if I want to write this in terms of product, what will be the expression? Average rate is equal to plus delta P divided by delta T, which is equal to plus P2 minus P1 by T2 minus T1. Okay, so average rate means you have to use the symbol delta. So this delta means it denotes the large change. It denotes the large change which we use it only for finding out the average rate of the reaction. Got it? Average rate between this R1 and R2, what is the rate? Between this P1 and P2 concentration, what is the rate? We are calculating for a certain interval of time. Got it? This is all about average rate. Now, what is instantaneous rate? What is instantaneous? So, from the name itself, we can able to understand, right? The rate of the reaction measured at a particular moment. The rate of the reaction measured at a particular moment, at a particular point of time is called as instantaneous rate. Okay. So, this is the expression for average rate in terms of reactant and product. Now, for instantaneous rate, what will happen? The delta T will go to 0. If the delta T goes to 0, then if I want to write the instantaneous rate, limit delta T going to 0 minus this. If I substitute, I will get dR by dt for reactant and dP by dt for product. So here what we are doing to represent the instantaneous rate, I am using the letter D. So the small d denotes the small change. Delta denotes the large change and D denotes the small change. We use delta to define an average rate and D to define the instantaneous rate. Okay, so let us see a graph. So this is a graph versus with the concentration and time. So here, as the time is increasing, the concentration is decreasing. Now, if I want to measure the concentration at this particular time T1, you see here, I am drawing a line, or I can call this line as a tangent also. Tangent means the line which touches the curve at one point. The line which touches the curve at one point. So this is the point in which the line is touching the curve, and the rate of the reaction at this particular point is called as the instantaneous rate of the reaction. Okay, it is determined graphically by drawing a tangent at time t on either side of the curve for concentration of R and P versus T and calculating its slope. Got it? We can also find the slope of this. If I take the slope of this curve, so this is the point where it touches, and if I can take a slope and I can find out the answer. Okay, average means delta, instantaneous means you have to put D. Otherwise, the expressions are going to be same only. Okay, if you're calculating the rate for a particular interval of time, it is average. If you're going to calculate at a particular time, at one moment, it is called as instantaneous. Very easy. Okay, now in the next topic, I will tell you how to express or write the expression for the rate of the reaction. Okay, how to write it. You might be already knowing how to write it. Okay, so far I have taken R giving P kind of reaction. Now I am going to take AA plus BB giving CC plus DD kind of reaction. So for this type of reaction, how will you write the rate of the reaction with respect to A? Can anyone tell me the rate of the reaction with respect to A? So here I don't have only the reactants. Along with the reactants, I have small a, b, c, d, which are nothing but the stoichiometric coefficient of the reactants and products. Okay. So for this type of reaction, very good Priyanka. For this type, but you have missed one thing, you know. Can you able to find out that thing which you have missed? Priyanka RM. Yeah, sign. And also one more thing. Yeah. Correct. Not one more thing, it is correct only. The remaining things are correct. Now, the rate of the reaction with respect to A is my rate of disappearance of A by stoichiometric coefficient. Okay. So, minus 1 by A. So, you all have to write that stoichiometric coefficient in the denominator. Okay. The remaining things are same. dA by dt. dA by dt. All of you are doing great, you know. Nagashri, Sneha, Kaushik. All of your answers are exactly correct. Now, what is the rate of the reaction with respect to B? So, I have to write minus 1 by B into dB by dt. That's all. Now, what will be with respect to C? C and D are the products, right? So, there we should not use minus. We have to use plus. So, the rate of the reaction with respect to C is equal to, yeah, very good. Yes, it is, it is plus 1 by C dC by dt, and with respect to D it is plus 1 by D dd by dt. Okay. So now all these things, all the rate of the reactions are going to be equal. So if I want to write the rate of this entire reaction, R will be equal to the each and every term. Okay. All the terms are equal to each other. Okay. So minus 1 by A dA by dt, which is equal to the B term, which is equal to the C term, and it is equal to the D term. Got it? So for any reaction which is given to you, you can write the rate of the reaction so easily by using this concept. Just one thing, if it is a reactant, put the coefficient in the denominator and put minus. If it is a product, put the coefficient in the denominator and write plus. That's all. Okay, such an easy thing. I hope this is clear to all of you. Am I right? Shall I go for the examples? Will you guys answer me if I give you some reactions? Okay. Let us try with some examples. Okay. Example number 1. So example number 1 is Hg plus Cl2 giving HgCl2. This is a reaction. How will you write the rate of the reaction? What is R? So I'll do for this. From next example onwards, you guys try to do. Okay. So what will be the rate of the reaction for this reaction? Means it is equal to minus dHg by dt, which is equal to minus dCl2 by dt, which is equal to plus dHgCl2 by dt. Because this mercury and chlorine are the reactants and mercury chloride is a product. That's all. A plus B giving C type of reaction. Okay. So now I'll go for example 2, in which I have 2Hi giving H2 plus I2. So what I have to write first? In terms of the reactant, what will come? It will be rate of the reaction will be equal to, here I have a coefficient, right? 2. So it is equal to 1 minus 1 by 2 dHi by dt, which is equal to dH2 by dt, which is equal to di2 by dt. Got it? Very easy. So now let me take one question to solve the thing from this concept. Okay. So here is the question. In a reaction, 2A giving products, the concentration of A decreases from 0.5 to 0.4 mole per liter in 10 minutes. Calculate the rate of the reaction during this interval. So how to calculate? So this is the reaction. Okay. This is the initial concentration and this is the final concentration. Got it? So this is the initial concentration and this is the final concentration. Because it is concentration of A is decreasing from 0.5 to 0.4. And the time taken is also given in terms of minutes. So how to calculate the rate of the reaction? As we know, what we know? We know how to write the rate of the reaction with respect to A, right? So what it is? It is equal to minus 1 by 2 dA by dt. It is equal to minus 1 by 2 dA by dt. Okay. So minus dA means, what is this dA? Final concentration of A minus initial concentration of A. So final is 0.4 minus initial is 0.5. And the time taken by it is 10 minutes. Okay. It is 10. So 0.4 minus 0.5. What is the answer? Minus 0.1. So that minus into minus will become plus. The answer for this entire term is minus 0.1. So minus and minus will become plus. And this 2 into 10 is equal to 20. Okay. Now if I solve this, I will get 5 into 10 to the power minus 3 mole per liter per second. Yeah. It is 0.005 mole per liter per second. Very good. Sham and Priyanka have got the exact answer. Very good, students. So why I am writing mole per liter per second? Because that is a unit for rate of the reaction in terms of concentration. Okay. So let me quickly summarize. Let me quickly summarize. Yeah, very good, very good. It is not per second, it is per minute. Yeah. FlexTech, you're from which school? May I know the name of your JNB? Exactly, you're correct. It is not per second, it is per minute. If possible, just let me know the name of your school in the chat box, okay? Yeah, let me quickly summarize the things which we have discussed so far. JNB Kadag. Okay, good. So let us go for the summary. So what we have studied, the rate of disappearance of reactant in terms of average rate and instantaneous rate, and for product in terms of average and instantaneous. Then if some reaction with some stoichiometric coefficient is given with respect to reactant, and this is with respect to product. Okay. Rate of disappearance of reactant, the whole divided by stoichiometric coefficient, rate of appearance of product divided by stoichiometric coefficient. So this is the summary of the topics which we have covered so far. Now, from this rate of the reaction topic, I have taken on previous year question for you guys to solve. So this is the question. And you guys have to give me the correct answer in the chat box within 15 to 30 seconds. Okay, let me see who is going to give first. So let me read out the reaction question. For a reaction 3A giving 2B, the average rate of appearance of B is given by del B by del T. The correct relation between the average rate of appearance of B with the average rate of disappearance of A is given in option. So in which option the answer is given? So let me see who is going to answer first for this reaction. This is the previous year question, which you can solve it very easily. Option C, sure. Everybody is going for option C. Great, great, great. Absolutely. Your answers are correct. Option C is the correct answer. So how did we get this option C as a right answer? So if some reaction is given to you like this, you need to write the rate. So what is rate of the reaction? It is equal to minus 1 by 3 del concentration of A by del T, which is equal to plus 1 by 2 del concentration of B divided by del T. So this is the rate of this reaction, right? Now the rate of appearance of P is given by this term. This is the term. Okay. So now the correct relationship between this A and B is you have to take this 2 to the other side. So it will go to the numerator, right? So rate is equal to minus 2 by 3 del A divided by del B. So this is given in option C. Very good, students. Within 30 seconds, you guys have answered, Really great. Really great. Now the second main topic. So first main topic is rate of the reaction. We have completed that. Now the second main topic is rate law, order, and molecularity of a reaction. So under this topic, we are going to learn four subtopics, which is rate law, unit of rate constant, elementary and complex reactions we are going to discuss, and at last, we will discuss the molecularity of a reaction. Okay, shall I go with the rate law? Are you all ready? Any doubt so far for anyone? If you are getting any doubt, please feel to ask. Okay. Okay. Don't get scared. Don't get shy. Throw all your shyness, everything. We are here to learn. Okay. Let me go with rate law. What is rate law? How to write the rate law for a given reaction? Before moving on to the rate law, let me start from the rate of the reaction. Okay, so in the previous topic, we have discussed about the rate of the reaction, right? So that rate of the reaction was directly proportional to the concentration of the reactant, right? Concentration. We have written del concentration of R, del concentration of A. So basically, rate is directly proportional to the concentration. If concentration of the reactant is more, then the rate of the reaction will also be more. If it is less, the rate of the reaction will also be less. So suppose if I take this reaction, here the concentration, here the reactants are A and B. So the rate of the reaction is directly proportional to the concentration of A and B raised to some power which is X and Y. And if I remove this proportionality symbol, I have to introduce a constant, and that constant is K. This constant is K. And this K is called as, this proportionality constant K is called as rate constant. It is called as rate constant. And this rate constant depends on the reaction and the temperature. Okay. This rate constant depends on the reaction and its temperature. Okay. So this expression is called as rate law expression. Got it? Now I am going to take the same set. I am going to take the same set of reaction, and I have written the rate expression for this reaction. And here you can see X and Y, right? So what is this X? X is the order of the reaction with respect to A, and Y is the order of the reaction with respect to B. Now if I want to find out the overall order of the reaction, what I have to do? I have to add these two, right? So X plus Y, which is equal to N, and this is nothing but the overall order of the reaction. So the sum of the power of the concentration is equal to the order of the reaction in the rate law expression. Got it? Clear for all of you? It's very easy. So this is the rate law, and if you sum up the powers in which the concentrations are having, then that is the order of the reaction. Very easy. Order can be determined experimentally, not by balanced equation. Order can be determined only through experiment. Okay, not through the theoretical balanced equation. So I can use any type of experiment. Okay, so you can use any type of experiment. It can be determined experimentally. But you cannot find out the order of the reaction just by seeing a balanced equation. So this is a balanced equation. Just by looking into this balanced equation, so here the coefficient is 2 and here the coefficient is 1. So 2 plus 1 is 3. So order of the reaction is 3. No, that is incorrect. Order of the reaction is equal to 3 is incorrect. So you cannot find out the order from the balanced equation. You can find it out only from the experiment. Okay, so just keep this point in your mind from this order of the reaction topic. Okay. Now with this concept, we will solve one question from this and then we will move on to the next. This is the question. The conversion of molecules X to Y follows second order kinetics. Okay. What is meant by second order kinetics? The order of the reaction is equal to 2. That is called as second order kinetics. Okay, order of the reaction is 2. If the concentration of X is increased to 3 times, if the concentration of the reactant X is increased to 3 times, how will it affect the rate of formation of Y? It is such an easy question. Let me see who is going to give me the correct answer first. So it is Nagashri who gave me the correct answer. Very good, Nagashri. How did you get that 9? How to get the 9? It is increased to 9 times. That is the correct answer. Many are giving. Yeah, yes. So first of all, if this type of question is asked to you in the examination, what you need to do, write the rate of the reaction for the given circumstance. So this is the given reaction. So if I want to write the rate of this reaction, how will I write? It is equal to rate constant into the concentration of X and raised to the power 2. Why I have put 2 here? Because the order of the reaction is 2. It follows second order kinetics. Now, the question says the concentration of the X is increased to 3 times. The concentration of the X is increased to 3 times. So, I am increasing the concentration of X by 3. Okay, so the remaining things are written as such. Now, this is the condition. If this is the condition, how will it affect the formation of Y? So here rate is equal to K into, so 3 square is 9. 9 into X the whole square. So which is nothing but 9K into concentration of X the whole square. So K into X square is nothing but the rate in terms of X. And this 9 is the new rate of formation of Y. So the rate is increased by 9 times. Rate is increased by 9 times. If it follows third order kinetics, what will be the answer? Instead of second order kinetics, if it increases by third order kinetics, what will be the answer? Yeah, very good. 3 into 3 into 3. Very good, students. 27. Great. Now, with the same concept, all of you are going to try this previous year question. Use the same concept, apply the same concept and find out the correct answer. For a certain reaction, the rate is given as this. When the initial concentration of A is tripled, keeping the concentration of B constant, the initial rate would. All of you try to solve this question. Which is the correct answer? Option B or option C? Neha is giving option B. Nargis is giving option C. B or C? Half of the students are going for B and a half for C. Which one is the correct? Most of you are going for B now. Nargis, it is B. Okay. Option B is the correct answer. Option B is the correct answer. So now let's check why it is correct. Concentration of A is tripled and concentration of B remains as such. Okay. So the rate of the reaction is equal to K into concentration of A is tripled. So 3 into A square. You should not touch this power, okay? All of you, many students will make mistake here in the power. They will change that 2 into 3. They will change this 2 into 3. No, that is not correct. Okay? So you have to change the concentration. Concentration. Okay? Concentration is triple and the concentration of B is constant. It is just 1 into B only. Okay, so now what will happen? 3 square is again 9. 9k into concentration of A to the power 2 and B to the power 1. So, and this is the initial rate. Okay, so rate is increased by a factor of 9. Okay, similar type of question, you know. Option B is the correct answer. Option B is the correct answer. So one more question. One more previous question we will try to solve from order of the reaction topic. Okay. So the correct options for the rate law that corresponds to overall first order reaction is. What is the question basically? We need to find out the option which has the order of the reaction equal to 1. We have to find out the option which the rate has the order as 1. D, sure. You guys are going in a very express, super fast speed, you know. You guys have already solved this question or what? Or now only all of you are seeing this? No, this is the first time for all of you. If this is the first time you are seeing the question and giving me the correct answer, oh my God, then it is really great, you know. Yeah, yeah. Option D is the correct answer. Because in option A, we have 0 plus 2. Or order is nothing but x plus y, right? 0 plus 2 is 2. And here 1 plus 1 is also 2. And here we have 1 by 2 plus 2. What is 1 by 2 plus 2? 5 by 2, right? 5 by 2. 5 by 2 means it is 2.5. Order is 2.5. And here we have minus 1 by 2 plus 3 by 2. So what is the answer? 3 minus 1 is 2 by 2. 2 by 2 is 1. So in option D only, the rate of the reaction is equal to, the order of the reaction is equal to 1. Very good. So this is all about the rate law and order of the reaction. Okay. Now next we will study the unit of the rate constant. Rate constant is denoted by which letter, students? It is denoted by the letter K. Yeah, very good. Now we are going to study the unit for that rate constant. Okay. So all of you listen carefully. I am going to give you one relation or formula. You are going to study or memorize only that formula. Okay. If you memorize that single formula, you can able to find out the unit of rate constant for any order of reaction. Order of the reaction can be 0, it can be 1, it can be 2, it can be anything. You can find out the order. You can find out the unit for any such order. If you're going to memorize the formula which I am going to give. Okay. Now let's see that formula. So this is the formula. Mole per liter to the whole power 1 minus n into per second. That's all. Okay. So here, what it is, let me write mole per liter power 1 minus n per second. This is the formula. Where this n denotes the order of the reaction. If the order of the reaction is equal to 0, so what you have to do? You have to substitute 0. So we will have 1 minus 0. So the unit is becoming like 1 mole per liter. This is mole per liter and per second. Okay. So if the order is equal to 1, what I have to do? I have to substitute n is equal to 1. So what will I get if I substitute n is equal to 1? So I will get 1 minus 1, right? Yeah. 1 minus 1 is 0. Anything to the power 0 is equal to 1. Are you all getting what I'm trying to say? Anything to the power 0. Anything to the power 0 is equal to 1, right? So this anything is mole per liter in our case. Got it? So the whole term is going to become 1. So we are left with only per second. So if the order is equal to 1, then the unit is per second or second inverse. What if it is equal to 2? What if the order of the reaction is equal to 2? What if the order of the reaction is equal to 2? What is the unit of rate constant if the order of the reaction is equal to 2? So it is mole per liter 1 minus 2 per second. So what is 1 minus 2? It is minus 1. So it is mole inverse. Liter is already there in the denominator. So that inverse and this inverse gets cancelled. So it is just liter and per second. Okay. So if the order of the reaction is equal to 2, then it is liter. This is liter. Okay, it is not 1. It is liter mole inverse per second. Both these forms are correct only. You can write liter mole inverse or mole inverse liter. Both are correct. Okay. Can anyone tell me the unit of rate constant if the order of the reaction is equal to 3? What is the unit of rate constant if it is equal to 3? Students, what is a unit of rate constant if the order of the reaction is equal to 3? Okay, so what I have to do? I have to substitute 3, right? So mole per liter, 1 minus 3, second inverse. So 1 minus 3 is minus 2. So it is mole power minus 2 liter square second inverse. So this is the rate constant unit. Yeah, correct, correct. So like this, you can calculate for any type of order by using this formula. Okay. Now let's do one previous year question from this rate constant topic. Here's the question. For the conversion of compound A to B, the rate constant of the reaction was found to be 4.6 into 10 to the power minus 5 liter per mole per second. The order of the reaction is. This is one of the previous year JEE question. Okay. So this is one of the numerical part question from JEE exam. That's why you don't find any options here for this question. Before I give the explanation, you guys are giving me the answer. How the order of the reaction is 2? How did you get the answer as 2? By seeing the value 4.6 into 10 to the power minus 5. Yeah, very good, very good, very good. Just by looking into the units, we can get the answer. We have liter per mole per second. This is the rate constant unit. This is the rate constant unit for the second order reaction. So the order of the reaction is equal to 2. Great. Great. Now I am giving you the previous year questions once I complete each topic and you are giving me the correct answer immediately. Will you be able to answer if I give you this question after completing some 5 chapters or 6 chapters? Will you all be able to give me the correct answer so quickly like how we are doing now? Yes, all of you. If you are in the continuous revision, if you are in the consistency path, which I have already told you in the first class, then you can able to give me the correct answer so quickly, like how we are doing now, for sure. Okay, just to follow what I have said. Very good. So here we are closing the rate constant topic also. Now the next is elementary and complex reaction. This is also the subtopic of this rate law, order and molecularity, elementary and complex reaction. Shall I go for this topic alone? Shall I complete this topic alone? You don't have any other class after this, no? This is the last class for today, right? Shall I take 3 to 4 more minutes to complete this? Are you all available? Okay. So without wasting much time, I'll go for the react topic. So the first is elementary reaction. Elementary. So what do you understand from the term elementary? The reaction which takes place in a single step is called as elementary reaction. So you see here, A is getting converted into a product in a single step. Means it is an elementary reaction. So examples, if I want to give, I can take H2 plus O2 giving 2H2, the formation of water reaction as an example for elementary reaction. So the one more point you should know about this reaction is, for elementary reaction, order of the reaction will be equal to the sum of the stoichiometric coefficient of the reactant. Order of the reaction is equal to sum of the stoichiometric coefficient. So these two are the reactants. These 2 and 1 are the stoichiometric coefficient for the reactants. And if I add this 2 and 1, what I will get? 3. And this 3 is the order of this reaction. So this is applicable only for elementary reaction which takes place in single step. Okay, order is equal to the sum of the stoichiometric coefficient. So this is the definition, and this is the very important point you are learning from this for elementary reaction. Now the next is complex. What is complex? The reaction which takes place in more than one step. The reaction which takes place in more than one step is called as complex reaction. And this is one of the example for complex reaction where 4 molecules of HBr is reacting with 1 molecule of O2. Totally 5 molecules are reacting with each other. Okay, 5 molecules cannot react with each other at a single point of time. Okay, so it occurs in a stepwise manner. Okay, so in step 1, what will happen? The first molecule of HBr will react with the oxygen molecule and it will form HO2Br compound. And in the next step, what will happen? This HOBr, which has formed in the first step, will react with the second molecule of HBr. So totally we have 4. So it will react with the second molecule and it will form 2 HOBr kind of thing. And in the step 3, what will happen? The 2 HOBr which is formed, that will react with the remaining 2 moles. So we have 4, no? So this is the first HBr, this is the second HBr, and these two are the third and fourth HBr. So these two will react with each other and they form the product H2O and 2Br2. Got it? So now this reaction takes place in 3 steps. So each single step is called as the elementary reaction. Okay? Each step is called as elementary reaction. Now to find out the overall rate of this complex reaction, what I have to do? To find out the overall rate of the reaction, what I have to do and how to determine that? The overall rate of the complex reaction is determined by the slowest step of that reaction. Okay, so here I have 3 steps. Step 1 might be slow. Step 2 might be fast. Step 3 is also fast. So don't worry, this fast, slow thing will be given to you in the question, okay? So they will give this thing to you in the question and they will ask you to find out the, uh, the rate determining step. The slowest step in a reaction is called as the rate determining step. Yeah, very good, Balmiki. You are correct. The slowest step in a reaction is called as the rate determining step. Rate is determined by the slowest step. That slow fast thing will be given to you in the question. You don't have to worry. So this is all about the elementary and complex. So the definition for both the reaction you have to study and the rate determining step thing you have to study. That's all. So this is all for today. We can close up the today's session. I hope each and every topic which we have discussed today is clear and it is very useful for all of you guys. Do any of you have any doubt from today's session? So before ending up the class, I would like to launch a poll. Okay, so just answer for the questions which I'm going to give you in that and then you can leave the class. Okay, thank you so much. So wait for a while.